Hey everybody, Lars here. Time for the second review video for Unit 5. In Unit 5, we're going to go over the stuff we learned about OOP in classes in the last video, but we're also going to look at two facets of object orientation that come along for the ride when we write our programs this way. One is called inheritance. It's where if we write a class and we want to create something kind of like that class, but a little bit different, well, we don't have to rewrite the whole thing. We're going to be able to go and use what we've written already and just add to it to add functionality or change things around. You'll see what we mean when we get into it. Second thing we're going to do is called polymorphism, which sounds incredibly complicated, but really isn't. I mean, it just means many changes, and what it means is you can have a method that has the same name for different objects, but it performs different activities depending on the context, depending what it is. You're going to see, we're going to write a class called animal, and then we're going to create other little classes, one for a cat, one for a dog, and they're going to have a method called speak. So when you run speak on the cat, you want it to say meow. When you run speak on the dog, you want it to say bark or woof, and there's ways to do that. So we're going to go over these two facets. Found a lecture from last semester, going to use that, and then afterwards I'm going to come back and we're going to do a couple of announcements, but it's going to be really quick because there's going to be yet a third video that's going to take place over the weekend. Today's Friday. I'm doing this Friday afternoon here in my office at Rutgers, and then I'll do the big announcements and make sure we're all on the same page. But as far as this class is concerned, we're in really good shape. So we'll get into all that when I do it later, all right? So now, without any further hullabaloo, here is your lecture on inheritance and polymorphism. All right, be back soon. Bye. Hey everybody, Lars here. As you know, we're Python crazy this weekend, so it's time to do the second review video for Unit 5. And this video serves not only as an overview of two facets of object-oriented programming called inheritance and polymorphism, but in the very beginning you get to see another class and you get to review how we use classes and how we use them to instantiate objects, and then we use those objects in our programs to do the things we need to do. So let's get right to it. Rutgers is playing Penn State tonight, and I don't know, not mad, but disappointed that I can't be there, because I can't with my leg. I just can't. I can't walk around with crowds, and I can't do things like that. I am getting around in the boot, but it'd be dopey for me to try to do something like that. But within 15 minutes, my leg would be killing me, so it would be stupid. But hopefully in a couple of weeks I will be able to do stuff. Enough of this. I digress. Let's take a look at this code that I already whipped up for us. I created a class called animal, and what we'll do is we'll review it and we'll run it, and then we're going to extend it, and then we're basically going to make it work not just for an animal, but for different, more specific animals like a cat, a dog, and things like that. All right, so you know what? Let's just run the code. Run module, boom. As you can see, I ran it before. All right, and then let's run over what is going on here. As you're going to see as we move forward, we finally got to the point where what we're doing isn't going to fit on one screen anymore. So we're going to be going up and down, up and down, up and down. All right, let's review what's going on here. Bunch of comments, not run. A class definition, also not run. So we don't start running code till we get down here. We see our class animal. We see our constructor, dunder, init, dunder. Self, which is the name of the variable down here, as you know now. We take two variables, name and weight, and we set them equal to instance variables. Then we have a getter and a setter for the name. You can see the getter just returns the name. The setter takes a name and resets the variable for us. And the same thing with weight, get weight and set weight. So we have getters and setters for our two variables. And then we have one little definition down here, one little method called speak. And because animal is kind of generic, I don't know what the animal is going to sound like, so I just say print sound. This is going to come into play later in the video when we talk about polymorphism, but we will get there. Do not worry. All right? So first thing we do, comment main. We don't run that. Here we go. I have a variable called A1, and I say with A1, I want to hold an object that you create with the animal class. And I want my animal to be called Fido, so I'm guessing I'm thinking dog. And I want Fido to be 35 pounds. So what happens here? I say, I want an object. Go use animal to make it. So I come up here and I say, do I have a class called animal? I do. Does it have a constructor? It does. Call the constructor, dunder init dunder, with self, which is A1, name, which is Fido, and weight, which is 35. So self.name is set to Fido. Self.weight is set to 35. And I now have an animal object with these two instance variables. Boom, done. I go to the next line, print. And then A1, get name. What is A1? It is an object created with the class animal. What is the method get name? I go to animal. Well, Python goes to animal and says init get name. Look at that, get name. It returns self.name. Self.name equals Fido. So I return the string Fido, which sits there. Then A1, what is A1? A1 is a variable that holds an object that was created with the animal class. Method get weight. I go to that class. Is there a method called get weight? There is. What does it do? It returns self.weight. Self.weight, what is that? Self.weight was initialized when we first created the object, and it is 35. Okay, so this print is going to print Fido and then 35, which is exactly what it does. Okay, so that's a small review of a class. Now you've gotten your dice class, you've gotten your student record class. The last video we did, you got your bank account class. Now you're getting an animal class, but we're going to create a whole family of classes here, because right now we're going to look at a facet of object orientation called inheritance, and it's one of the key components of object-oriented programming is this idea of code reuse. When I create a class, when I create something, I want to create it so that it can be used in more than one circumstance. So when I create this animal class, I create it kind of as a base for other classes to inherit from and use as I get more specific in my code. So let's say, for argument's sake, I want to create a cat. Okay? So instead of doing class cat, well, I am going to do class cat. Hold on. Let's say class cat. Okay? Here, let me give myself some room here so you guys can see. So, class cat, and then I would, basically come here and do my constructor, do my getters and setters, do my But I like what I see here in animal. I'm going to have, my cat's going to have a name, my cat's going to have a weight. I got getters and setters already written. Wouldn't it be nice if there was a way that I could just tell cat, hey, can we just go use all the stuff we did in animal? Right? Well, that's exactly what inheritance is. Basically, what we're going to do is we're going to tell cat to inherit from animal. So everything we do with cat, we can go back and use all of the things we've done in animal. Okay? But there's a trick. Basically, and what we're going to do it right now. First thing we're going to do, dunder init dunder, is we are going to define the constructor for cat. So what are we going to do? We're going to take the variables we took for the animal, but we're going to add one here too. We're going to add color. Okay? Here is the trick right here. I have self, name, weight, color, but I'm building on animal. So what do I want to do? I want to go build an animal object that I'm going to then add to. Think about Russian dolls. Think about Mr. Potato Head and having that base and then adding things to it. When I inherit from a class, I want to real quick go create an object of that thing and then bring it down to me, and then I'm going to build on top of it. So I actually want to call the constructor from the class I inherit from, and you'll learn as you get more involved with object orientation that the classes we inherit from, we usually call them the superclass. So what I'm basically going to do is I'm going to say animal. Now, we're not used to calling things this way, but basically, you see, look at that. It's giving me everything I can do with animal. We're going to say animal, and then we're going to call the constructor. Now, usually the constructor gets called automatically, but we're going to call it explicitly here. And I'm going to say self, which is weird because usually when we call things, we don't use self, but here we want to because we have a subclass going and calling the constructor of the superclass. And then I'm going to send it name. I'm going to send it weight. Okay? I'm not going to send it color because animal doesn't know what color is. Animal expects self, name, and weight. Okay? Boom. Now, because I have color, I'm just going to treat it like any other instance variable and say self.color equals color. Okay? And that's it. Okay? I went and got an animal object that cat is using, and then I defined color. Okay? So that's a little bit nuanced. You take a while, soak in that, get used to it. But basically, I'm calling the constructor of the parent class and saying, hey, give me an object real quick, and then I'm going to build on it, and that's how I'm going to do cat. Okay? Now, when I made my cat, I added a attribute. So I need getters and setters for that attribute. So I'm just going to say get color self return self.color and def set color. We haven't really used setters a lot because when I do the bank account, you don't really use setters, so you get to see them here. A setter is just a way to reset a variable. Real simple. Self.color equals color. Okay. Same thing we did in the constructor when we initialized it. We're just changing it. Okay. And then, because I'm going to talk about polymorphism later, I am going to go right over speak. But what I'm going to do is I'm going to print meow. Okay? Look at this. Look how fast we built a whole new class. So, you can see that. Let me bring the code up here. So now we have a class, cat, which inherits from animal. So it can use get name, set name, get weight, set weight, all of those things. And you can also use getters and setters for the color of the animal. And now it has its very own speak method that says meow. Okay? So let's use it. It's going to be more understandable if we use it. Should I keep the nah, it's just going to convolute things. I'm going to have a variable now called C1. And I'm going to say make it equal to cat. And I'm going to say cat's name is Felix. Weight is 15 pounds. We don't want a fat cat. And I will make Felix orange. Okay? Then, why did that not just go to the next line? Why did that go down there? What am I doing wrong? Well, you know what? I will, like everything else, I'll find out. Then I am going to print C1.get name, C1.get weight, C1.get color. And then on its very own separate line, that's going to blow up somehow, and I'm going to find out why. What is it? Well, we'll find out. I'm going to run C1.speak because it prints it out itself, and I need to do that. Okay? Now, I'm going to run this code. Hopefully it runs, although I think something's going to break. Something's wrong with the syntax here. Let's see. Feelings. Oh, you know what? You know what? It shouldn't care. I'm mixing and matching my delimiters there for my strings. That might have something to do with that. Well, they were balanced in there. All right, well, we're going to find out. All right, we're going to get a cat object, and I'm going to trace through this after we run it. So let's just run the thing and see what we get. Ta-da! End of line while scanning. There's my problem. All right, so now we got that figured out. And now, get color is not defined. Is something misspelled here? C1 dot get color. Yay. So, when did that come up? All right, Felix 15, orange, and then meow. So, let's trace through this code. As you know, comments, class animal, class cat gets put in memory. Main is a comment. The first time we really do anything is I have the variable C1, and I make it equal to, I want to get an object, and that object is created using the class cat. And then I give it a string Felix, an integer 15, and a string orange. So, cat. Does class cat exist? It does. I want to run its constructor, self, which is C1. Name, Felix. Weight, 15. Color, orange. We're in good shape. Animal, dot init. I want to go run the constructor of the parent class. What is animal? Do I inherit from something? I do. Look at that. Cat inherits from animal. So let's go up and look for animal. I find animal. I run the constructor. Self, C1. Name, Felix. Weight, 15. So what do? I create an animal object. It contains two instance variables, name, Felix, weight, 15. And that gets brought back down here. Okay? Now I define self.color as orange, and I'm ready to rock and roll. Okay? I have an object, cat, with three instance variables, the name, the weight, and the color. So then I return back here to the main call, and C1 points to my object. So now print C1, get name. What is C1? C1 is a variable that holds an object that was created with cat. So I go to cat. Is there a method called get name? And it, get color, set color, speak. No, there isn't. But we're going to get out of Dodge, because then Python says, okay, did cat inherit from something? It did. It inherited from animal. So now we're going to go back up to animal. Is there a method called get name? Init. Get name? Yes, there is. And what does it do? It returns self.name. Self.name was defined up here when we ran the animal constructor. And what does it contain? The string Felix. So when we run this, we're going to get the string Felix. C1.getWeight, same story. C1 is a variable that holds an object that was created with a cat class. I go to the cat class. Is there a getWeight? Blip, 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 blip. No, there is not. But I look up here and I see that my class inherited from animal. So I go up to animal. Is there getWeight? Init, blip, blip, blip. Yes, there is. GetWeight. Return self.weight. Self.weight was defined up here in the constructor. It equals 15. So I'm going to print 15 here. Now, a little bit different. C1, what is it? It's a variable, points to an object. That object was created with the cat class. I go to the cat class. Get color, does it exist? Get color, yes, it does. So I found it in my cat class. I'm going to return self.color. Self.color was defined right here in the cat constructor, and it returns the string orange. So I'm going to get Felix, I'm going to get 15, and I'm going to get orange. And what happens? Exactly that. Felix, 15, and orange right here. Okay? So now, hopefully, as you're watching this go through, you're getting a little bit of flavor for what, inheritance is all about. Now, we're going to touch upon polymorphism. And polymorphism is a weird-sounding word, but if you break it down, just think of poly means many, and morph, could mean change, but it could also mean form. And that's the context in which we use it in computer science. We think of polymorphism as many forms. And what we've done here is I say C1.speak. And what is C1? C1 is a variable that holds an object that was created with a cat class. So I go up to cat. Is there a method called speak? Yes, there is. So I run it. Print meow. Meow. Boom. But if that didn't exist and I said C1.speak, let's show you. It says sound. Okay? Why does it say sound? C1.speak. C1 is a variable that holds an object that was created with a cat class. Cat class. Does speak exist? 1, 2, 3. No, it doesn't. Commented out. But I inherit from animal. So let's go up to animal. Does speak exist? Yes, it does. Look at that. So I print sound, and that's what happens. Okay? But what you notice, and what's different from when we did what the hell happened there? So what's different from when we did our getters and setters and stuff like that is both of these methods have the same name. And you might be thinking, well, cat inherits from animal. Why don't we just go rewrite animal and make animal say meow? Or why don't we do something like that? Well, we can't really do that because animal might be used by other things. Animal's kind of generic. Back in the day, something like animal would be called an abstract class, where we don't really want to instantiate it. We want it to sit there and be used or inherited by other classes as what's called a base class. So, but in our case, we really don't want to rewrite it. What we want to do is what's called override it, or create one for ourselves so that when it's called, we definitely use that one instead of going that. Because I know my cat says meow. When I do a dog class, my dog's going to say woof or bark, So I want to write over it. So that's basically what polymorphism is about. Things can have the same name, but depending on their context or what object is using them, they have different behaviors. Okay? So if I have a class and I say speak for a certain animal, it's going to act that way because it's that class. If I say speak on my dog, it's going to say bark. If I say speak on my cow, it's going to say moo. It's going to do different things based on the context. And I can do that in Python by writing a speak method for every different class I have. And you will always default to the one in your class like we did with cat right here, and you'll always say meow. Okay? It doesn't really get more complicated than that. You'll learn more in the next video about the difference between two different things called overriding and overloading. Overloading, Python doesn't really support, but polymorphism has to do with overloading too, because what overloading is that you can have a method with the same name defined differently by the amount of arguments you give it. If you take the name of a function plus its arguments, that's usually called its signature. And you can have different signatures in different object-oriented languages, Java, C++. In Python, we don't really support that. We don't really support overloading. Although, you can, forget what I was about to say. I was going to bring up the topic of operator overloading, but we don't want to get that complicated. So don't worry about that nonsense. Basically, we handle polymorphic behavior in classes in a Python context with overriding things and just making sure that we, have our house and things in order when we do polymorphic stuff, like a speak method for a class for an animal, okay? So it doesn't get more complicated than that. You're not going to get some long chain convoluted example in a quiz, or you're not going to be asked to do something super complicated as far as polymorphism is concerned, all right? I want you to understand the basics of it. Object-oriented programming, there's big topics to cover. One is the general idea of classes and creating blueprints and then getting objects by using that blueprint and then using these objects to complete our tasks. That's the big overall idea. Then there's an idea which we completely skip over, called encapsulation, and that is private data, public data, different things along those lines. If you know C++ and Java, you're probably saying to yourself, where is the encapsulation stuff, blah, blah, blah. I completely skip over that, because what you learn very quickly when you become a professional programmer is that a lot of other programmers are ignoring that too, and they just make everything public. Maybe it's not the best way to write code all the time, but a lot of times everything is available to everything else. There are ways to hide data from other modules and do things. There's private, there's public, there's protected if you're a C++ programmer. So there's different ways to deal with hiding things from other things. I don't bother with that. Like I said, I got a lot of stuff to teach you, and I got 15 weeks to do it. So I got to make choices. One of the choices I make is that encapsulation kind of goes, but I wanted to mention it. Okay, because like I say, it's all exposure. I want to make mention to you. I want you to know about these things. That way, if another programmer brings up encapsulation, at least you've heard the term. You can go look at Wikipedia now or Google it, and you can get smart. The two things I do want to go over and show you are inheritance and polymorphism, and you've gotten them in this one. You understand now inheritance. Inheritance is when I've got a class, and I want to go use another class that's already been written. Code reuse makes sense in a logical order. I can build a hierarchy of classes that all build up on other ones, and boom, boom, boom. You would see that I could now write a class that inherited cat. And when I inherit cat, I'm really bringing along animal for the ride as well, because cat inherits from animal. So you're building hierarchies. You're building chains that go up and down and use these different classes. Okay? And polymorphism, like you said, is just different forms. It's if I write a method for one object and I write another method for another, and they do similar tasks like speaking or running or doing things. Well, those two different things, depending on their context, are going to do things differently. I can write two different methods and give it the same name. As you can see, animal has a speak method that prints sound. Cat has a speak method that prints meow. Same thing, but we make it work. That's basically many forms or polymorphism, okay? Polymorphism also deals with, different signatures and being able to write methods that have different signatures and do different things, but Python doesn't support overloading. We do overloading in a different way in Python. Don't let that make your brain hurt, all right? All right, then that's basically where I'm going to stop as far as this video is concerned. The last video for this unit is basically some neat features and some cleanup stuff. Okay, we're going to go over these things called class variables you've seen so far. Self.name, self.weight, self.color, what are called instance variables. When I create an object, my object has all of those variables all to itself. And those are the variables that are for just that object. Well, there's another kind of variable. I was going to say class of variable, but that wouldn't convolute terms too much, would it? There's another kind of variable called a class variable, where you can set up a variable and every object created with that class can access those variables, which is a neat thing to use. It's very useful with like scoreboards and stuff if you do game programming and stuff like that. We're also going to review the polar opposite of the constructor, his evil twin called the deconstructor. And we're going to learn how to delete objects, and we're going to learn that we can set up a method to run when we delete objects, and it's called the deconstructor. And then we're going to discuss some of the stuff we were just discussing 3 minutes ago with overriding versus overloading and stuff like that. And then we're going to set up one big final program where I'm going to show you that classes can go into libraries just like functions can. So we can take all of these things that we can go stick them in a library, our own library, and basically just import classes the way we import functions and the way we import from libraries. Okay, so we're going to do all that stuff in video 3. This is video 2. Watch it, absorb it, learn it, love it, live it, and we are going to move forward. Hey everybody, I'm back. We are going to move forward. Basically, announcements, like I told you, I'm not going to hit you with a lot because we have another video coming in a couple of days, and then I'll go through announcements then. The only thing I'm going to do is remind you that April 16th is the day that you have to get your proposals in. So make sure you're talking with your groups. Make sure you're talking about your projects. A couple of groups are putting things in forums and asking me to read them. That's a good thing. I have no problem doing that. Shoot me an email. If you have an idea and you want me to take a look at it before you go through all the trouble of creating the big bad proposal, and you want to give me like broad strokes, go ahead. I have no problem going into forums and looking at what you're doing and seeing what's going on and giving you my opinion and some ideas and some things along those lines. So if you want to do that, go ahead and do that. I believe Hans has graded the assignments for Unit 4. I still have to bang out the quizzes. I plan to do that this weekend, so hopefully we'll be getting you some Unit 4 grades soon. And over the weekend, I'll be getting you the third and final review video for Unit 5, and I'll be posting the assignment. So you can finally eyeball the assignment and see what you're going to be up against. I may do that later on tonight, or I may do that over the weekend, okay? Don't freak out. Read it, think about it, watch the videos, Google around a little bit. You're going to have fun with it, and you'll enjoy it, all right? Then I'm going to get out of here, but either Sunday or Monday, you're going to get the last video, and I hope at that point to get you all of your resources for Unit 5, and then you can just go crazy. You'll have a couple of weeks to read all the resources, work on your project, get everything together, and get it done. Plus, you know, not just your, when I say project, I mean your assignment for Unit 5, but you'll also be able to take some time and work on your final project for the course. All right? Then I'm getting out of here. You enjoy your weekend, and I'm going to get you that third video either sometime around Sunday or Monday. All right? You be good. Bye.